I'm only. I think you may guess today's topic, broken line with the jump. This is the case where there is a jump at the turning point. Then how to do it, how to make your mother. All right, let's see. It is simple. Okay, broken line with the jump. They are cases where there is a jump, discontinuity at the bend point of a broken line, linear model. For example, when performing regression analysis of the annual total expenses Y of first class and deluxe hotels based on the number of rooms X, a noticeable jump occurs at around 200 rooms. Specifically, for deluxe hotels with X number of rooms greater than equal to 200, since the fixed expenses constitute a larger proportion of the total expenses, the intercept becomes higher. Although the total expenses are higher than those of first-class hotels, the expense per room has a smaller slope compared to the first-class hotels, like this. Okay, this is, say, first-class hotels. This is for deluxe hotels. Okay, then the broken line regression model that includes such a jump is defined as follows. yi equal to beta 0 plus beta 1 xi1. x1 is number of rooms. Beta 2 xi1 minus 200. 200 is what? Bend point, turning point. x1 minus 200, xi2. x2 is what? Dummy variable. When x1 greater than 200 takes 1, x1 less than 200 takes 0. And plus, this is a jump. Beta 3 xi3, x3 means is also dummy variable, x1 greater than 200, x1 less than 200, takes 1 and 0 respectively. Okay, this term added, this one include the jump. Example, let's see. Suppose a company distributes imported goods to two warehouses, A and B, for storage. If the imported quantity is less than 250,000 units, it is stored in warehouse A, and if it exceeds 250,000 units, it is stored in warehouse B. Warehouse B is, I think, bigger than warehouse A. The recent data for 10 importations, including the quantity X and storage cost Y. Storage cost, they have to analyze storage cost are as follows. Storage cost Y here, $1,000, unit is $1,000, and X is 1,000. It is the amount of imported goods, right? Okay, X and Y, there are 10 samples. Then the scatter plot of this data is shown as follows, like this. The scatter plot of this data is like this, and from here, like that. Okay, so these two pieces have different slope and, of course, different intercept, right? This intercept term is around here, and the slope is like this. This part is almost 0, and the slope is like that. From from this scatter plot, it can be observed that there is a jump at 250,000 around here, right? Around here, 250,000, and the slope of the line changes for values less than and greater than this point. This point slope will be different. Therefore, broken line piecewise model with the jump is y equal to beta 0 plus beta 1 x. X is what? The amount of volume of imported goods. Beta 1 x plus beta 2 x minus 250 times some dummy variable. U is dummy variable. It will take 1 if x greater than equal to 250, mu u equal to 0 when if x less than 250. And another term here, another one, beta 3, beta 3 b I, b is also dummy variable. So I think you understand why dummy variable is very useful variable in these cases. V plus epsilon. When this data is fitted to simple linear model, you don't know how to do it, or you only know simple linear regression model, then you may apply this data to simple linear model. The result obtained as follows, like this. Therefore, estimated regression line is very, very satisfactory as follows. This is what computation result. INTERSTAT 5.57, and the p-value here 0.000, and beta 1 is 0.025, p-value 0.000, and r square, I don't show you the r square value from the computing result. R square is 0.96, very satisfactory result, but it's not all. If you know that there exists jump and there exists different slope and intercept, then you may apply what? Broken line model, broken line with a jump model, this model, right? Then you get result, same process, but you define different model, and you define u and v here, right? Dummy variables. Then you get result like this. See 0.04 x, 0.0245 beta 2 hat, and minus 0.34 v, okay, is p-value is 0.006. Then you can summarize or rewrite this result like this, okay? The turning point is 250. So when 250, in other words, this dummy variable u equal to 0, and this one is also 0 when x less than 250, then the remaining thing is what? This one, 2.9625.04x, right? When x less than 250. When x is greater than equal to 250, this is going to be 1. So you calculate differently. You calculate this, you summarize this result, then 8.7479 plus slope is 0.0155x. So this is neat result, right? Okay. When they are two turning point, means like this. This one, this way, and something like this. Okay? That kind of result, that kind of model can be applied to some data from research laboratory. I guess, sometimes. So you can add one more bending point, and you have to define dummy variable between this area. So you can extend simple broken line regression model to some other cases, this kind of cases. Okay, that's it today. Thank you. Bye.